Hey everyone, welcome to our YouTube channel, and in this video we are going to discuss a very important topic from the applied electronics, that is the root mean square value of the alternating current. So basically the definition I've given here, but before going to this definition, let us discuss in a very simple diagram what basically is the meaning of the RMS value. So let us say if I draw a graph here, let us say this is your y-axis and then this represents your x-axis. And let us draw an AC signal or an alternating current signal like this. So this diagram over here represents your AC signal. So the peak value here, which is represented, is given by IM. Now what happens is that there are certain factors associated with this AC signal over here. So what happens is that there is this one factor which is, let us say, 0.707 multiplied by IM. So this factor would certainly lie somewhere in the middle portion over here. So if I draw this in a middlemost segment, so this value that we have got in this segment, this is called the RMS value. Now let us see how does this function arrive. So basically what happens is that the root mean square value or the RMS value is expressed by the DC current which while flowing through the given circuit for a given time produces the same amount as produced by an alternating current when flowing through the same circuit for the same time. So for example, if you allow the alternating current and the direct current to flow through simultaneously from a wire, so RMS value is that value of the DC current which technically produces the same amount of the heating effect. And it is also known as the effective value or the virtual value of the alternating current. Now, however, in actual practice, the terms RMS and the effective value are used more extensively. And the symbol that we use for the RMS is IRMS, or simply I. Now, what happens is that the RMS value may be determined by taking the mean of the squares of the instantaneous values of the current over one complete cycle. So let us say the value of I is given as square root 1 divided by 2 pi integration 0 to 2 pi, and then we have I square d theta. So basically this particular expression here kind of represents the RMS value by taking out the mean of the squares of the instantaneous values of the current over one complete cycle. Now we also know that the value of this particular I, that is the small one here, will be represented by I max multiplied by sine theta. So this is the value that we are going to substitute in this particular expression over here, and let us see how does this change. So that means the value of IRMS, let me write this as IRMS, this will be equal to square root of 1 divided by 2 pi integration 0 to 2 pi I square max multiplied by sine square theta d theta. So this is how this would be represented in this kind of a situation over here. So if you notice, all I've done is just change the value as per the integration rules. Now let us rearrange this again. So this would be integration of square root of I square max divided by 2 pi integration of 0 to 2 pi, and then inside this we have sine square theta d theta. Now after this, all we have to do is just integrate this particular value and then we will get the answer. Now as per the normal rules of integration, first we'll have to convert this into the trigonometric formula. So the value of IRMS would be equal to square root of I square max divided by 2 pi, and then the sine square theta would be rewritten in a trigonometric terms as 1 minus cos square theta divided by 2, and then we have a d theta over here. Now let us solve this. So this would be equal to integration of I square max divided by 4 pi, and then we have, when we substitute the upper and the lower limit, we have theta minus sine square theta divided by 2, and the limit goes as 0 to 2 pi. And when we substitute all the values together, this entire integration comes out as 2 pi So let me write this as this is equal to square root of I square max divided by 4 pi multiplied by 2 pi outside the square. And when you solve this, finally what you get as your answer is the value that is I RMS is equal to 0.707 multiplied by I max. So this is the RMS value of the current that we were looking for. So technically what is happening here is that this is the same value of the current multiplied by this factor that is 0.707. So I hope that this video was informative enough, and for more such videos don't forget to subscribe to our YouTube channel. Thank you so much for watching. We'll meet soon. Goodbye.